So chapter 18 is about amines and amides. Today we are going to cover amines and tomorrow I'm going to cover amides. Today we are going to concentrate on amines and tomorrow we are going to start amides. So what is an amine? Amine is a functional group. Amine Amine is a functional group that contains carbon and nitrogen bond. Amine is a functional group that contains carbon nitrogen bond. Amide is also a functional group where carbonyl carbon, everyone see the difference. This is called carbonyl carbon. When carbonyl carbon is attached to nitrogen, this is called amide. That's the difference. So can I make a statement? Amines and amines are organic compounds that contains what? Nitrogen. That contains nitrogen. Can you guys think of compounds in nature that contains nitrogen that are useful for life? Can you guys think of examples where compounds containing nitrogen or that are very useful for life? Can you please send me a chat message? Can you guys think of any compound? Fertilizers, yes, fertilizers contains nitrogen. Fertilizers contains nitrogen, yes, that's one of the reasons why before you start using fertilizer, you need to do a soil test. And the soil test will tell you exactly how much nitrogen, how much potassium, how much phosphorus you need for your lawn. Yes, that's one of the good examples. Fertilizer contains nitrogen. What else? Can you guys think of any other compounds? Laughing gas. Yes, laughing gas contains nitrogen, but it's not organic compound. Fertilizer is an organic compound. Laughing gas is not organic compound. Laughing gas is not organic compound. So there are many nitrogen containing compounds. There are many nitrogen containing compounds that are important to life. Like amino acids. Amino acids contains nitrogen. Proteins are made of amino acids, so proteins contains nitrogen. Nucleic acids. Nucleic acids contains DNA and RNA contains nitrogen. So you guys can see chapter 19 is about amino acids and proteins. Chapter 20 is about enzymes, which contains nitrogen. And chapter 21 and 22 is about DNA and RNA. Yes. Now, if you guys think about some amines, many amines are used in hospitals. Many amine containing compounds are used in hospitals because they exhibit I keep forgetting the spellings, strong physiological activity. Strong physiological activity and are used as medications. As they're used as sedatives. They're used as sedatives. Like, for example, they're used as stimulants like nicotine. Nicotine is a stimulant. Nicotine contains nitrogen. And like nicotine. What about caffeine? People likes to drink coffee in the morning. Caffeine. And there are morphine. Morphine is used in hospitals, yes. All these compounds contains nitrogen. All these compounds contains nitrogens like decongestants, dopamine, histamine. All these compounds contains, like cocaine, they all contains nitrogen. So you guys can see the significance of organic compounds that contains nitrogen. Organic compounds that contains nitrogen. So that's one of the reasons why we have to learn about amines and amides. Amines and amides. So can I erase this? Please send me a chat message. Can I erase this? Now we are going to look at naming amines. Naming amines. IUPAC ends with amine. Common name also ends with what? Amine. So the rules are same. What's the basic rule? The basic rule is find the longest carbon chain. Find the longest carbon chain. Then what do you do? Start numbering from the end. Close to what? Nitrogen. Start numbering from the end close to nitrogen. Name the compound as alkane. Just like alkane, you name it. Now what you do? Replace that E in alkane with amine. That's it. Those are the rules for IUPAC naming amine system. In IUPAC, the rules doesn't change. Find the longest carbon chain. Then you start numbering from the end close to nitrogen. Name the compound as alkane. And then you just replace E in alkane with amine. Then you get what? E in alkane with amine, and you get the complete name with amine. Now, when you're using common name has prefix. Common name has prefix. And then you have suffix. Prefix is alkyl name because nitrogen is connected to alkyl group. Carbon chain can be named as alkyl. Your suffix is amine. Your suffix is going to be your amine. So you have a prefix and then you have a suffix, and the common name is named as alkyl amine. Okay, let's look at naming some amines. So let's do some example problems. So the simple amine is this. The simple amine is CH3NH2. So because we have only one carbon, the normal alkane name is methane. The normal alkane name is methane. Now I'm going to replace that E with amine. It becomes methanamine. This is your IUPAC. This is your IUPAC. Methane, you are replacing that E with amine, it becomes methanamine. That's the IUPAC name. Now, what will be the common name? Now, please look at here. This is carbon chain is our alkyl group prefix, and suffix is going to be amine. So CH3 is called what? Methyl. CH3 is named as alkyl group, so it's a methyl. And NH2 is called amine, so the common name is going to be what? Methylamine. That's the difference in naming IUPAC and common. That's the difference in naming IUPAC and common. Next. Please name this compound. Please name this compound, both IUPAC and common. Please send me the messages in chat. Please name this compound. Please name this compound. So you have only two compounds. You have only two carbons in the longest chain. Everyone see that? The longest chain is only two carbons. The longest chain is only two carbons. So if you have two carbons, what is the normal alkane name? Normal alkane name is ethane. The normal alkane name is ethane, and replacing E with amine, it becomes ethanamine. So this is going to be your IUPAC. And what is the common name? The common name is going to be what? CH3CH2 is called ethyl. CH3CH2 is called ethyl. So ethyl and amine becomes ethylamine. So that's the difference in naming IUPAC and common. Name this compound. Now I'm drawing the line structures. Now I am drawing the line structures. Please name this compound. So look at how many carbons we have. 1, 2, 3. That's our longest chain. 1, 2, and 3. That's our longest chain. Please send me your answers. So the name of this compound is propane. Now I'm replacing this with amine. So the IUPAC name is going to be propanamine. The IUPAC name is propanamine. As a alkyl group, it's called propyl. So the common name becomes propylamine. The common name becomes propylamine. Now name this compound. Try to name this compound. Please try to name this compound. Now this compound also contains only 3 carbons. 1, 2, 3. That's my longest chain. That's my longest chain, 3. But what is the problem? What is the problem? 1, 2, 3. Everyone see the difference here? 1, 2, 3. Everyone see the difference of location of NH2. Now the name of this compound becomes what? 2-propanamine. 2-propanamine is our IUPAC. And common name is going to be how it looks. The attachment of the longest chain is happening in the middle carbon. So this group is called isopropyl. I don't know how many of you remember. So if the NH2 is not on number 1, you have to give the location for NH2. You have to give the location of NH2. So the location of NH2 is on 2. So the name of this compound is 2-propanamine. And if I'm using this as an alkyl group, then it's called isopropylamine. Name this compound. Please try to name this compound. Please try to name this compound and send your answers. So how many carbons we have in the longest chain? 1, 2, 3, 4. You have 4 carbons in the longest carbon chain. You have 4 carbons in longest carbon chain. So if you have 4 carbons in the longest carbon chain, what is a normal alkane name? No, normal alkane name is butanamine. Yes, butanamine, but the location of amine is at 2. So the IUPAC name is 2-butanamine. The IUPAC name is 2-butanamine. Now, common name. Everybody is making mistake on common name. Some people are forgetting about the location of amine group. You can't forget about the location of amine group. And a lot of people are confused on common names. What do we call alkyl group that's happening on second carbon? I want everyone to go to page number 435 in your textbooks. Please visit page number 435 in your textbooks. That table contains all the alkyl groups. You guys already forgot all the branches. A lot of people are coming up with so many creative common names. All of them are wrong. Yes, there is only one person who got it right until now. Page number 435 contains all the branches, chapter 12. Page number 435, table 12.5. Table 12.5 contains all the substituents. So someone has to tell me what is the common name after looking at the table. There's only one person who got it right. There is only one person who got it right. So the IUPAC name is very, very easy. Yes, now you guys are getting the right answer. The name of this compound is sec-butylamine. The name of this compound is sec-butylamine. That's a common name. The name of this compound is sec-butylamine. Next. Name this compound. So clearly you guys can see we have a lot of substituents, so there is no common name. Please send me your answers. In alphabetical order. In alphabetical order with all the substituents, the name of this compound is 1-bromo, 2-chloro, 3-methyl butanamine. Now we are done with easy ones. Now we are going to do a little bit complicated ones. Let me draw the condensed structures. It's much easier. Now, how do we name this compound? Clearly, you guys can see nitrogen is breaking the longest carbon chain. Everyone see that? Clearly, you guys can see nitrogen is breaking the longest carbon chain. This is not our longest carbon chain. Why? Because nitrogen is in the middle. Nitrogen is in the chain. That's the problem. Now, when you have a situation like this, find the longest carbon chain attached to nitrogen. So this is our longest carbon chain attached to nitrogen. Yes? Now, if this is the longest carbon chain, how do we name this chain? This chain is named as ethane. But because it is amine, so the name of this chain is what? Ethanamine. Just the name of this chain is ethanamine because eth for 2 carbons. And this longest carbon chain is attached to nitrogen, so it's ethanamine. Now, what is this group called? This group is called methyl. And methyl is attached to what? Nitrogen. So the name of this compound is N-methyl. Why I'm saying N-methyl? Because methyl is attached to what? Methyl is attached to what? nitrogen. So that's the reason why I have to use N-methyl. That means nitrogen is attached to methyl. Ethanamine. Ethanamine is also attached to nitrogen. So this is your IUPAC. So clearly you guys can see how I'm writing this name. Nitrogen is breaking the longest chain. So when nitrogen is breaking the longest chain, you still have to find the longest chain attached to nitrogen. And that longest chain is named as ethanamine. The remaining part of the molecule is named as alkyl group. So which alkyl group is attached to nitrogen? Methyl is attached to nitrogen. So this is called N-methylamine. Now the common name is, can I use both of them as alkyl groups attached to nitrogen? So the common name is going to be ethyl. CH2CH3 is called ethyl. Methyl. Ethyl. CH2CH3 is called ethyl. CH3 is called methyl and ends with amine. So the common name is ethyl methylamine. That's the difference between IUPAC and common. In IUPAC, you have to find the longest carbon chain. Please don't forget that. In IUPAC, you have to find the longest carbon chain. Please do not forget that. That's the reason why the name of this compound looks like N-methyl. Why we are using a prefix N? Because methyl is attached to nitrogen. So we have to place N. We use N only in the IUPAC name, not common names. So N-methyl ethanamine. Next. So how do we name this compound? Clearly, you guys can see nitrogen is breaking the long chain. So we still have to find the longest carbon chain. The longest carbon chain is this. If that's the longest carbon chain, the name of this chain is going to be propanamine. The name of that longest chain is going to be propanamine. And if you guys are looking at here, you have CH3 attached to nitrogen. CH3 and CH3 are called methyl groups. So the name of this compound is N, N. Why I'm using the location twice? Because two of them are attached to nitrogen. So N, N, dimethyl propanamine. N, N, dimethylpropanamine. That's your IUPAC name. That's your IUPAC name. What is the common name? Anyone? What is the common name? The common name, we don't use N's. In common name, we don't use any prefix N. The common name is going to be dimethyl because I have two methyl groups. Can I say dimethyl? Dimethyl propyl. This longest chain is called propyl and the name ends with amine. So dimethyl propylamine. Dimethyl propylamine. Diethyl propylamine. Everyone got this? Now let's see how many of you can do this. Can I clear this? Please name this compound. Well, clearly you guys can see there won't be any common name, but there is no common name for this, clearly because there are so many branches, but there is a IUPAC name for this. Please name this compound. So please look at here. This is our longest carbon chain. This is our longest carbon chain attached to nitrogen. It is clearly attached to nitrogen. So let's number the carbon chain. Why we have to number the carbon chain this time? Because it's not at one, it's at a different location. If it's at a different location, we have to number the chain. So this chain is called 2-pentanamine. Why we are calling it 2? Because nitrogen is attached to carbon at 2. And in the longest chain, we have 5 carbons. In the longest chain, we have 5 carbons. So it becomes 2-pentanamine. Now we know what we call this group. This is methyl, and this is ethyl. This is ethyl, and this is methyl. So in alphabetical order, the name of this compound becomes N-ethyl, N-methyl, because ethyl and methyl, they both are attached to what? They both are attached to what? Nitrogen. So we are using N-ethyl, N-methyl, 2-pentanamine. Pentanamine. So clearly you guys can see it is N-ethyl, N-methyl, 2-pentanamine. Next. What if NH2 is attached to a benzene ring? No common name. Yes, there is no common name for this. Only IUPAC. There is no common name because the longest chain contains 5 carbons. We have common names only up to 4 carbons, not 5 carbons. You can name it 5 carbons, but it gets complicated for your class. For your class, we go up to only 4 carbons. So what if NH2 is attached to benzene ring? It is called, anyone? Do you guys remember from chapter 12? When a benzene ring is attached to, when a benzene ring is attached to NH2, it's called aniline. There is a significance of aniline. Aniline was first isolated in 1826 from indigo plants, and it is used to make many dyes, especially blue color. You guys see blue color jeans? That blue color is coming from aniline. It gives that color. It gives color to wool, cotton, and silk fibers. Everyone see this significance of this compound. It is also used in the synthesis of acetaminophen. What is acetaminophen? It's an anti-inflammatory drug. So this is the applications of aniline. Aniline was isolated in 1826 from indigo plants, and it is used to make many dyes like blue jeans. So benzene ring attached to what? NH2 is called aniline. Now name this compound. Please name this compound now. If benzene ring attached to NH2 is called aniline, what is the name of this compound? So automatically one has to go to this carbon. If this carbon is 1, this carbon is 4. So what is the name of this compound? What is the name of this compound? Yes, 4-bromo aniline. Or instead of using 4, we can use para-bromo aniline. It's the same thing. You can use either 4 or you can use para. We don't use 1 anymore. Why? Because aniline means what? Aniline means benzene ring with NH2. So we don't need to use again 1 in front of aniline because benzene ring with NH2 is called aniline. So simply the name of this compound is 4-bromo aniline. Now try to name this compound. There is no common name for the benzene rings, ma'am. There is no common name for benzene rings. Name this compound. Name this compound. You still have benzene ring attached to nitrogen, but this time nitrogen has CH3. Can anyone come up with a name for this? Yes. The name of this compound is N-methyl aniline. Yes, you guys got it right. N-methyl. Why it's N-methyl? Because clearly you guys can see N-methyl group is attached to nitrogen. So it's N-methyl. But nitrogen is still attached to benzene ring. So it's aniline. So the name of this compound becomes N-methyl aniline. N-methyl aniline. Okay, next. Now let's look at the classification of amines. So we have three types of amines: primary, secondary, and tertiary. If nitrogen is attached to what? Only one carbon group, it's primary. If nitrogen is surrounded with two carbons, it's secondary. If nitrogen is surrounded with three carbons, then it becomes tertiary. So now tell me, what type of compound is this? Is this primary, secondary, or tertiary? This one. Please send me your messages. I have drawn a compound. What do you guys think? Is it primary, secondary, or tertiary? Yes, this is secondary. This is secondary. Sometimes they use these numbers: primary, secondary, tertiary. So this is secondary. What about this amine? So easy to identify primary, secondary, and tertiary. So this is tertiary. So please copy the properties of amines. So the primary and secondary amines primary and secondary amines contains NH bonds. Clearly, you guys can see from examples on the top, NH bonds, but tertiary doesn't have any NH bond. Tertiary has only nitrogen carbon bonds. Everyone see that. That's one of the reasons why tertiary amine cannot form hydrogen bonds. So because of these NH bonds, when you dissolve primary and secondary, they can even form hydrogen bonds with water. But if you compare just primary and secondary, who has the ability to form more hydrogen bonds? Clearly, you guys can see in primary amine, we have two NH bonds. In secondary amine, we have only one NH bond. So primary amines can form more hydrogen bonds than secondary amine. Nitrogen is not as electronegative when compared to oxygen. So hydrogen bonds in amines are weaker than in alcohols. What it means is the boiling point of amines is lower than boiling point of alcohols. Please copy these. Okay, some of you are asking for answers for 18.2, 18.4, and 18.8. I will do that once I'm done with this topic. I'm sorry, I forgot about it. I just went on, but we will do that. We will go back and look at the answers. We will go back and look at the answers once I'm done with this topic. So please copy the properties of amines. Once you're done copying, please let me know. Please let me know once you are done copying through chat message. Please send me a message if you're done copying. Please, everyone, not everyone is responding. Everyone has to respond. Is everyone done copying? Okay, 2 more minutes. Okay, let's continue. Amines are organic bases. Organic bases. What do I mean by base? What is a base? What is a base? Anyone? Bases are what? Bases contains OH, yes, but what is the other definition of a base? Bases are proton acceptors. Yes. pH higher than 7, that's true. pH greater than 7, that's true. But the basic definition for a base is bases are proton acceptors. Proton acceptors. Because amines are bases, they like to react with what? Because they are bases, they like to react with what? Anyone? Acids, yes. So let's take an amine. Acids like, I don't know, acids like HCl. So amines are organic bases. Amines are organic bases. So they like to react with acids like HCl. Well, just to give you an example, the amines in the fish contains amines. amines in fish causes that fishy odor. So to remove that odor, what do we do? Yes, we add lemon. Yes, we add lemon. The amines in fish causes that fishy odor, and this is neutralized by squeezing a lemon. That's exactly what we do. So the reaction between acid and base is called the reaction between acid and base is called neutralization reaction. So amines are organic bases. Yes, amines are organic bases. So what they do is they like to react with acids like HCl to form salts. So we're going to look at that right now. Let's take an example. So what happens here? Amine is acting as a base. HCl is acting as acid. Now acid wants to donate a proton and base wants to accept a proton. So please look at here, I'm moving a proton. I am moving a proton from acid to a base. I am moving a proton from acid to a base. Now what happens? What happens? CH3NH2 becomes CH3NH3. So nitrogen is accepting that proton to become NH3 plus because proton comes with a positive charge. So when nitrogen accepts that proton, it becomes positively charged. Now the positive charge left, what is remaining on chlorine? Negative charge. That negative charge balances this positive charge and stays next to it. Or you can write plus Cl minus, it doesn't matter. So the name of this compound is methyl. Now please look at here. Nitrogen has 4 bonds with positive charge. It's called ammonium. Methyl ammonium chloride. This salt is called ammonium salt. The general name is ammonium salt. The exact name is, the salt name is methyl ammonium chloride. CH3 is called methyl. NH3 with 4 bonds is called ammonium. And Cl minus is called chloride. So the name of this compound is methyl ammonium chloride. And because this is a salt, is it water soluble or insoluble? Anyone? Is it water soluble or insoluble? Yes, water soluble. Because this ammonium salt is water soluble, many drugs of amine, like Sudafed, Benadryl, so this is one of the reasons why a lot of drugs, example Sudafed and Benadryl, drugs like Sudafed and Benadryl are amine salts or amine drugs. They are converted to what? Ammonium salts by using this reaction so that they are soluble in water and body fluids. Can I move on? Now, I want you guys to think about there is a cocaine, ammonium salt, and then there is a crack cocaine. Cocainium ammonium salt is a white powder. You guys saw that in movies, right? They are transporting white powder. Because why it's a white powder? Because it's ammonium salt. Crack cocaine is amine. That's the difference between cocaine, white powder, and crack cocaine. This is the difference between cocaine, ammonium salt, white powder that you see being smuggled illegally on the streets. That's the salt, ammonium salt. Cocaine contains amine. Okay, but you saw in these movies that they start heating the cocaine, white powder, and they're going to get crack cocaine. So what is the meaning of crack cocaine? So this crack cocaine, the name got for amine, it got a nickname crack cocaine because when you heat this compound in a spoon, it will start making this cracking noise. Addictive. So cocaine is usually obtained from anyone. Coca leaves. Coca leaves. But if you know chemistry, you can make it in your lab without any coca leaves. We can make it from chemicals. Now everyone see the difference between cocaine, ammonium salt, and crack cocaine. Cocaine ammonium salt is a white powder. Crack cocaine is a simple amine. That's a major difference. Okay, let's do one more example for this reaction, neutralization reaction. So if I take this amine, and if I add HCl, what happens? HCl donates a proton, so I'm transferring proton. This becomes CH3, NH becomes what? NH2 plus CH3. Now this NH2 plus is balanced by Cl minus. You can place Cl minus here, or you can place it on the top or bottom. Because ions, they don't have a bond. They just like to sit wherever the positive charge is. They're just balancing a positive charge with a negative charge. So you can place it as plus Cl minus, or just place it next to positive charge. It doesn't matter. And the name of this salt is dimethyl ammonium chloride. Dimethyl ammonium chloride. There is one more reaction. After that, we are going to take a small break. There is one more reaction I would like to discuss. Are you guys done with copying this? Are you guys done copying this? Yes? Okay. Okay, one more reaction. So what happens if we dissolve this amine in water? Same thing. What happens when you dissolve amine in water? Well, now amine is acting as what? Base. We know that's the nature of this base. If this is acting as a base, water is forced to act as an acid. Water is forced to act as an acid. So what happens? Acid donates what? Proton. Same thing happens. Now you form so when water leaves, what is left? OH minus. OH minus. So proton is grabbed by nitrogen. So NH2 becomes NH3 plus. What is left over when proton leaves? OH minus. That OH minus balances out NH plus. And the name of this compound is methyl ammonium hydroxide. Instead of chloride, this time you have hydroxide. OH minus is called hydroxide. Methyl ammonium hydroxide. The only difference between previous reaction and this reaction is in previous reaction, we are using HCl acid. Here we are using just water. But when you use water, what happens? Because NH2 is acting as a base, it's forcing water to act as acid. So it grabs a proton from water to form ammonium hydroxide. And the major difference is this reaction is reversible. The other reaction is irreversible. So you guys can see this reaction is going back and forth. So this dissociates back into amine and water. So let's look at the answers. Do you guys have any questions on 18.1? Do you guys have any questions on 18.1? Nope, no questions. Okay, what about 18.2D? Okay, let's solve 18.2D. I'm going to clear this. 18.2D. 18.2D, they're asking IUPAC name and common name. So let's draw the structure. I'm just drawing the line structure. So this is the line structure for that molecule. So it doesn't matter which one you pick as the longest carbon chain. So let's say this is my longest carbon chain. So I have two carbons in the longest carbon chain, and these two groups are ethyls. So N, N, diethyl ethanamine. So N, N, diethyl ethanamine will be your IUPAC. And the common name is going to be triethylamine. The common name is triethylamine. Any other questions on 18.2? Well, one by default, you don't need to put one by default, but if you want to place one, you can place it. By default, you don't need to do it. Any other questions in 18.2? Any other questions on 18.2? Okay, let's move on to 18.3. Any questions on 18.3? Do you guys want me to draw any in 18.3? Now, any questions on 18.4? Any questions on 18.4? C. Okay, let's solve C. 18.4 C. First, I'm going to solve A, and then I'm going to solve C. 18.4A is dimethylamine. Amine contains nitrogen. Yes. And they are saying dimethyl. So just place methyl. Methyl. And nitrogen forms 3 bonds. So the third bond has to be hydrogen. So dimethyl, I'm placing 2 methyl groups, one on each side. And we know Nitrogen forms 3 bonds. So this is dimethylamine. Next, C. So clearly in C, they're asking for N diethylaniline. So first let's draw aniline. We know aniline is this benzene ring attached to what? Nitrogen. If nothing is on nitrogen, then it becomes NH2. But the problem is on nitrogen, we have 2 ethyl groups, diethyl. So ethyl, ethyl. That's it. And I'm checking nitrogen, and nitrogen has 3 bonds. So I don't need to place any hydrogens. Nitrogen has 3 bonds. So I don't need to place any hydrogens. Any other questions on 18.4? Any other questions on 18.4? No. Okay, now let's move on to 18.7. Any questions on 18.7? Any questions on 18.7? Okay, no. Okay, let's move on to 18.8. Any questions on 18.8? Let me give you guys answers for 18.8. The first one is secondary. The B is tertiary. C is secondary. D is secondary. And Please write down the definition for heterocyclic amine. A heterocyclic amine is a cyclic organic compound with 2 or more nitrogen atoms. You guys can see these are 5-membered rings. Because of their significance, you guys have to remember the structure and name. You guys can see this 5-membered ring is called pyrrolidine. If the 5-membered ring contains double bonds inside the ring, it's called pyrrole. If a 5-membered ring contains 2 nitrogens in a ring, it's called imidazole. It's called imidazole. Now we are going to look at 6-membered rings. I wish I have 6-membered ring. I have only 4-membered rings here. You guys can see there is a nitrogen inside the ring. Oh, let me draw the whole thing again. This is a mess here. You guys can see the challenges me drawing these structures with a mouse. This is a 5-membered ring. So we have names. This is called piperidine. The second one is called pyridine. The second one is called pyridine. Pyrimidine. And then the last one is called purine. And the last one is called purine. Well, we know the aroma of black pepper is due to piperidine. The aroma of black pepper is due to piperidine. And also, if you guys think about our DNA, RNA contains what? Our DNA and RNA contains purine and pyrimidine rings. Yes. If you're done copying this, I'm going to show you guys more examples. For example, nicotine contains pyridine ring, and sedamine. Sedamine is a sleeping aid. It also contains a heterocyclic ring, which is piperidine. I'm going to talk about that. So if you guys done with this slide, please let me know so that I can show you guys more examples. So what is a heterocyclic amine? Heterocyclic amine is a cyclic organic compound. It has to be a cyclic organic compound with two or more, one or two nitrogen atoms. If you guys are looking at all these rings, they contains either one or two nitrogen atoms. And they are crucial in a lot of compounds. Are you guys done copying this slide? Please let me know. Very few people are responding. Everyone needs to respond. Are you guys done copying this slide? Okay. Now let's draw the structure for nicotine. Let's draw the structure for nicotine. Clearly, you guys can see it contains pyridine ring. It contains pyridine ring. This is a pyridine ring attached to pyrrolidine. Pyrrolidine is a 5-member ring. This is nicotine. So you guys can clearly see nicotine contains pyridine and pyrrolidine rings. So the one on the left is six-membered ring. This is pyridine. The one on the right is pyrrolidine. And some of you are thinking, sir, this is supposed to be hydrogen. No, it doesn't. It doesn't need to be hydrogen. It can be anything. The main idea here is nitrogen with a five-membered ring. Nitrogen with a five-membered ring. Well, we know nicotine is a stimulant. We all know that. It's a stimulant. Nicotine is a stimulant. So what nicotine does is nicotine increases the level of adrenaline in the blood. It increases the level of adrenaline in the blood, which increases heart rate and blood pressure. Which increases heart rate and blood pressure. And we also know nicotine is addictive. Why it's addictive? Because it activates pleasure centers in your brain. Now we know what are heterocyclic amines. Now let's define alkaloids. Alkaloids are so if the heterocyclic amines are produced by plants, they are called alkaloids. Example, conine, conine causes respiratory paralysis obtained from hemlock. Another example is caffeine. You guys all know the effects of caffeine. Morphine. Morphine. Do you guys know where morphine comes from? Morphine and codeine. Where we can get morphine and codeine from? Which plant? Heroin, oxycontin or contin, so all these are natural alkaloids. They are obtained from plants and they have addictive side effects. For example, cocaine is an effective anesthetic, but if you take it regularly, what happens? The user can become completely addicted. Morphine is also effective painkiller. It's an effective painkiller. The problem with morphine is it's also addictive. So all these are natural alkaloids. Natural alkaloids. So what are alkaloids? Alkaloids are heterocyclic amines that are produced by plants. When you obtain from a plant that has a psychological effect, they are called alkaloids. They are called alkaloids. Now, okay, let's look at the answers for 18.21. Name the following heterocyclic amines. I'm looking at a 6-membered ring with a nitrogen. It's called piperidine. B, I'm looking at 6-membered ring with 2 nitrogens. It's called pyrimidine. Next, C, I'm looking at a 5-membered ring with nitrogen with 2 double bonds inside. It's a pyrrole. Next, 18.23. I'm looking at 18.23. It's a Ritalin. Ritalin is a stimulant used for ADHD. And they're asking for heterocyclic amine. I'm looking for a ring with nitrogen, and there is only one ring with nitrogen, and that ring is on the right-hand side. There is only one ring with nitrogen, and that ring is on right-hand side, and that ring is 6-membered ring with nitrogen. 6-membered ring with nitrogen with no double bonds is piperidine. Next, 18.25. 18.25 is the structure of serotonin. I'm looking for nitrogen in a ring. There is only one ring with nitrogen, which is next to the benzene ring. And that ring contains 5-membered ring. It's a 5-member ring with double bonds inside the ring. So it's a pyrrole. It's a 5-membered ring with the double bonds inside the ring. It's a pyrrole. Any other questions on these problems, the way you look at them? Everyone saw how I'm looking at these molecules? Yes, please respond to the chat. All I'm looking for is it a 5-membered ring or 6-membered ring? Does it contains nitrogen? Then I can tell. If it contains double bonds, then I can tell what it is. So that's it for today. We are done with amines. Tomorrow I'm going to finish up amides. That's it for today.